This is problem number 8 on the sample test problems for test number 2. The radius of the moon is approximately 1,740 kilometers. What distance on the surface of the moon corresponds to 1 degree of latitude? So first we need to figure out what that phrase 1 degree of latitude means. So we'll draw the moon, and so I don't know if the moon has an equator, but let's suppose that it does. So we'll draw the equator, and then that part is supposed to go behind. And so what does it mean to say 1 degree of latitude? Well, what you imagine doing is having somebody who's sitting here at the center of the moon, and with one hand, this person points straight out to the equator there, and with the other hand, the person is going to point up 1 degree. Now, this angle right here is definitely a lot more than 1 degree, but we'll just pretend it's 1 degree. And this 1 degree of latitude is corresponding to this point that this person is pointing to up here. And they didn't have to point there. They could have pointed to the 1 degree point over here, or in fact, there's a whole circle of 1 degree points. And so I guess we would say that that circle is the 1 degree latitude line. And what we're interested in then is what distance on the surface of the moon corresponds to that 1 degree. And so I guess what we really want is this thing in green. I just want to know how far am I walking on the moon if I want to start at the equator and walk to one of these points that the guy in the center of the moon is pointing to. Okay, so we do have a nice little formula. If we call that thing S, then we have this formula that says S was equal to theta times R. So that S, the arc length, is what I'm interested in. That's the distance. So S is equal to theta. So theta is 1 degree times the radius of the moon, which is 1,740 kilometers. And so it feels like the answer is just 1 times 1740, which is 1,740. But that just seems entirely too big. If the radius is 1,740, so that means that this line right here is 1740, and I have grossly exaggerated a 1 degree angle. 1 degree is a lot smaller than that. It doesn't feel like there's any chance that this thing right here is the same distance as that thing, right? It looks like the curve, the part on the surface of the moon, is significantly smaller. And the problem here is that this formula that we're trying to use only works if theta is in radians. If theta is not in radians, you get ridiculous answers like the one we just came up with. So all we need to do to use the formula is convert from the degrees to radians, and we know we do that by multiplying by pi over 180. So this is our answer right here. 1 times pi over 180 times 1740. So 30.37 kilometers. And that answer seems a lot more reasonable than the 1740 we first got.